Okay, I'll go ahead and show you guys the solution I came up with. So if you weren't able to get it, don't worry. You can kind of go back to it later. So this part should be pretty familiar. So here we're just resetting the URL. So I'm just making a new variable called URL2. Use URL open, fetches the API from iJSON. We talked about that. So what we're fetching is going to be the items.item, which gives us the iterator of repos. And so this is kind of going to be the not tricky, but the part that actually does the work. So we have what we're looking at is the field called language. And so I told you that some of the items don't have a language. And the way their API works is instead of returning an empty string, they return none. And if you have a field that returns a none for a lot of these functions, you get an error. So the first thing we have to do is filter out all of the repositories that don't have a language. So there's a function called filter. Essentially what it does is it takes as the first argument, you can pass it a lambda, but basically it has to be some callable which will tell filter which repositories to keep. So the second argument is going to be the iterable. And so since we've already defined keyfunc, we can use that same keyfunc in filter. And so the way filter works is it will get a repository and it will see what the value of the field language is. And if that field is equivalent to true, basically if it's not empty, then it keeps it. So we save that into what I call cleaned. So next we have to sort it. So we just use a function sorted, pass it the argument cleaned, and then the same keyfunc. And then now we can group by, and so we group, the first argument is going to be records, and then again we're still using the same keyfunc. So now that we have our groups, we can iterate through the groups. And so for each group, the key is going to be the name of the language, and then group is going to be an iterable of repositories. And so what we want is a sum of all of the watchers within that group. And so for here, we can use a list comprehension. So in this case, G, this represents a repository. So we just say, look at the number of watchers, sum everything up, save that into count, which I just abbreviated CNT, and then we can print a tuple of the key and the count. So does anybody have any questions about that?
I'm getting a small subset of data. Watching it, right?
Okay, you okay?
Yeah.
Okay, anybody else? Any questions? Yeah.
That's a general question.
Yep.
Reality, for example, you say we should not report without the language. And part of the question. In reality, sometimes you always have to include dirty data when you're trying to extract information. Can you point on how the best way to go about that?
Yeah, so the question was, I guess, essentially like dealing with messy data. Yeah. That's kind of what you're dealing with. So, right, so one thing that you can do, in this case, the issue is that instead of, if the GitHub returned an empty string, it would be fine, because you would just have, the key would be an empty string. So the problem is that it's none. So in this case, you need to create a new iterator of repos where any language that was none has now been replaced with an empty string. And so to be like more correct, you should probably do that for every field that could potentially return none. But essentially it comes down to knowing what the data is like. And there's a few convenience functions that will do that for you. So the Meza library that I'm going to get into later has a function that helps you do that. So, yeah.
Could we have taken an approach like wrap keyfunc and a newfunc that returns some
right?
It doesn't have to. It just returns none. So key func. So item getter takes a argument, in this case language. It returns a function called key func that we call key func. So you can think of key func as just like a lambda that takes a repository. It looks in the field language and it returns whatever the value is. So if you give key func a repository where the language is none, it's just going to return none. So
I'm talking about counting the ones that don't have a line.
oh, if you wanted to count them. Oh, exactly. If you wanted to count them, yes, you could modify key func to be exactly, yeah, just what you said. So, and I get.
Just do a lambda, which is just a string of the argument, because the string of none returns a string. So,
So there's a few ways you can do it. You could either just create a new key func with your custom lambda, and basically you would say like, essentially it would be a lambda x and then x of language, and I would just say or empty string. That would probably be the easiest way to do it. Another thing you could do is you could write a new item getter, which I've done before. So you write a new item getter that accepts the default. So that's another way. So then the key func you get back just returns the default. So, yeah. Any other questions? Okay. So the solution is also online. You can take a look at that. Okay, so now we're gonna get into Meza. So kind of like I said before, it's a toolkit for processing tabular data. Some of the benefits are that it's pure Python. It runs on PyPy, which speeds up your code a ton. It's lightweight. Yeah, I think it's great. You install it pretty easily. Just pip install Meza. And again, this is just the link to the IPython notebook. So this is just in the presentation notebook if you want to follow along. Okay, so now we're gonna just, yeah. It's the same URL as before, nothing new. Just wanted to show it again. Okay, so now we're gonna be doing the same things we did before, but just using the Meza library, just to show you how it can make things a little easier. So in order to read data, we're still gonna use URL open, but from the Meza library, we're gonna look at the IO module, and there's a function called read JSON. And the way it works is pretty similar to the iJSON. So you call read JSON, you give it the file-like object, and then the path that you want. And then you get back. So one thing I should mention, so in Meza, I call everything records. So records is just an iterable of dictionaries. Excuse me. And so to get the first repository, like we've been doing before, we just call next on records. And each repository is the dictionary, and we can access all the fields, same as before. And so here, so I'm showing you, so for this URL, the number of records in the list total, so it's actually 30, but we call it next, so now we have 29 left. So just keep 30 in mind, because it'll come into play later. Okay, so now, if you want to read a different file type, you can just use a different reader. So in this case, we're doing read CSV. Need some water. So Meza will accept a file path. So if you have a local file path, it accepts that. It also accepts a file-like object. So here, we're just creating a fake CSV file with a file-like object. And so when you call next, excuse me. When you call next, you just get back the next record. And in this case, it's going to be a dictionary. And so one of the cool things that you can do, since a lot of these functions kind of have a unifying data structure, there's another reader that's called join. And what join does is it accepts two file paths. And so in this case, we're going to get the second page from that GitHub API. So now URL3 is going to be page 2, and files is going to be an iterator of file-like objects. So I didn't mention map, but in Python what map does is it takes a function, so in this case URL open, and then it applies to it the arguments that you give it in that second argument position. So it's going to pass URL2 to URL open, and it's going to pass URL3 to URL open. And URL open returns a file-like object, so the result of map is going to be 2 file-like objects. So does anybody have any questions about that? I haven't used it yet. I'm just creating the files that I need. So I now have 2 file-like objects. And so now to read them, so we pass in the files. And so I don't think I've introduced this. So in Python, so they have two things you can do. When you're calling a function, you can call it with a star, which is essentially the same thing as if I said file1 equals something, file2 equals something, and then instead of calling join with star files, I would say join file1 comma file2. So it's a way of not having to kind of specify all the arguments, because if you wanted to fetch 100 pages, you wouldn't want to have to write out file1, file2, file3, or whatever. You could just store everything in an iterator and then put the star and then the files, and then Python under the hood, and it's called unpacking in Python. We'll just expand it out. So what join does is it takes that iterator of either file paths or file-like objects, the extension, which in this case is going to be JSON, and then the path, which is the same as before. And so, yeah, exactly. It's under the hood. It uses iJSON. Yep. So now we get back, the iterator of records, and we're calling out repo as the first one, like we did before. So you can get the name, you get the language. But the interesting thing here is now we have 60 records, right? 59 plus 1. So each page had 30 records, and so what join did is it essentially parsed each one, put everything together into one iterator. So that's one of the cool things you can do. So any questions about that? Yeah, so the question was about scraping data. So there is an HTML reader where if you give it a web page, it will extract the first table found in the HTML. If you want something more complicated than that, then you'd have to kind of do your own type of scraper. But Meza by itself does CSV, XLS, JSON, XML, SQLite, like a ton of file formats. But everything that you read returns an iterator. And so see here, I showed you read CSV. So if it's a file path, you can actually just import read, and depending on the extension of the file, it will pick the correct reader. But if you give it a file-like object, or if the file path isn't like .csv or .xml, then you have to specify the reader that you want. So that's another convenient thing.
So for join,
Right.
gave an extension.
Right.
You weren't arguing that told it which reader.
Exactly. Yep. Okay, so now we're gonna do a bit of transformation. So first, just gonna do some merging. So in this case, we have 3 records. Each record has a different key. And when you use merge, what it does is it creates one record where each record in the list or iterable just kind of adds itself. And I did it this way since they all have different keys. If any of the keys overlapped, so say it was that last one, instead of C400, it was A400, it just overwrites. So it's kind of like a last one wins type of thing.
Is this similar to dict update?
Yeah, works like dict update. Only this is returning a new thing instead of modifying. So yeah, so Meza is, I forgot to mention, yes. Meza operates, Python doesn't have immutable dicts, but Meza operates under a functional programming paradigm. So everything returns something new. You're never going to be modifying dictionaries in place with Meza. So that's one of the differences to every other data processing library you'll find from Python. Okay, so next is group. So we went over group with pure Python. So in Meza, it sorts under the hood. So you just call a group, you give it your records, and then you give it the field that you want to group by. So in this case, we're saying group by item. So under the hood, it'll do the sort and then the grouping for you. And it works just like kind of the built-in group. So when you call next, you kind of get that tuple of key and group. So here the key is A, and then the group is going to be the list of items. So one thing I didn't mention, so in the built-in grouper, group is an iterable. So what Meza's group does is it takes an optional aggregator. And if you don't pass an aggregator, it just assumes the aggregator is list. So it applies list to the group. So that's why the group that you see here is a list, because it just uses a list as a default. But you could pass it your own aggregator, and the aggregator has to be a function that takes in that iterable of groups and then return something new. But the default is just list, so you get back the list. Yeah. No, it's just a function. You can do whatever you want, right? But so, right. So here, group. So there's a keyword, aggregator. So the aggregator just has to be a callable that takes an argument, which is going to be that iterable of groups. So you can make that function and return whatever you want. Yeah. This one?
Yeah. So at that point, maybe you can say
so at this point, yes. Right, because, So if you, at this point, right, so there's key and group, and at this point, group is the realized list of the group. If you don't want it to be consumed, you could just pass in a new aggregator where it's iter. Okay.
The merge, is it correct that if you have two dictionaries with the same key, it'll just take the last?
Last one wins. Yep.
Just like a update reduction.
It's like update, but it's not overwriting. It's just creating a new record. Right. Yep. Okay. Wait, I went too far. Okay, so now, so I'm gonna read in the JSON file like before. So in this case, I'm showing you a new function that's called cut. So what cut does is it takes in an iterable of fields that you want to keep, right? Because if you remember from the JSON, from the GitHub API, there's like maybe 20 or 30 different fields for each repository. So in this case, we only want 5 fields. So we use a function called cut. So you give it the iterator that was returned by the read JSON, and then the list of fields that you want to display. And like everything, that Meza returns an iterator. So cut here is just a generator expression. There's another function. I think somebody was asking, how do you not consume the items of an iterator? So you use this function called peek. So what peek does is it takes an iterator and it returns a tuple. So a tuple of a new iterator that has not been consumed, and then preview, which is a list of by default, the first 5 items of that iterator. But you can configure it for however many you want. So as you can see here, now, instead of cut being a generator, cut is an iter tools chain. So in itertools, there's a function called chain, which lets you kind of append one iterator to another iterator. So under the hood, that's what's going on. But as you can see, preview is now a list, because you can call len. You can't call len on an iterator, only on a list. So now preview has 5 items, and you can just view the first item in preview.
Preview is already married to a list.
Yep. Any questions?
Say again, what's the difference between a chain and what you started with?
So what we started with, I mean, if you really think about it, they're the same thing, just give them different names. But all it means is that chain is essentially one generator followed by another generator. That's all it is.
Just a pen for generator.
Yeah. So it's like what he said is it's append for generators, but not exactly, because append modifies in place, whereas everything under itertools does it functionally. So instead of modifying it in place, it returns a new thing. Yeah. Any other questions? Okay, so there's preview. You can use indexing because it's a list, so you just give it, index it by 0. Oh yeah, and what I was showing you, so because we said cut, we only gave it the fields that we want. So now instead of having a dictionary with a ton of fields, just the fields that we want. Okay, and somebody else was asking, okay, well, if you have messy data, what do you do? So there's another function called FillEmpty. In this case, you give it the iterator, the value that you want to use for empty records, and then the fields that you want to look in. So in this case, since some of the records had a language that was none, what this is saying is that look in the field language, and if the value is essentially evaluates to none, then fill it in with the empty string. But you can make value be whatever. If you wanted to say n/a, or if you wanted to say no language. And then what you get back is a new iterator of records where instead of the language being none, the language now is an empty string. Okay? And then after that, I'm showing you there's a function called pivot. So how many people here have used Microsoft pivot tables? Wow, fewer people than I would have thought. Okay. So what a pivot table basically lets you do, so a lot of times you'll have data where instead of being, a nice structured format where everything kind of fits nicely into rows and columns, they might have some weird thing where, you might have one field which is called Python, and another field that's called C, another field that's called JSON, when really you want a field that's called language, and the value should be Python and JSON and C. So what pivot lets you do is it lets you convert from one structure to the other structure, and basically it's it's another word for that is called normalization. So there's like normalization and like denormalization, and so it basically lets you go from one data structure to another data structure. And so in this case, what we want to do, so there is so what we want to do is look at the language and each of those records, and we kind of want to see how the groups that have a wiki compare to the groups that don't have a wiki. And so the item that we're going to be using to kind of compare the two is going to be score. And then the operation that we're going to apply to that is min. So once we kind of do this, and I'll show you. So here, we are getting the minimum score for each of the records, and it's broken out by language. So those are all the different languages. And also by whether or not it has a wiki. So essentially, these are all the repos that don't have a wiki. What is the minimum score? So in the GitHub API, there's just a field that's called score. And so I'm just using that. There's no formula to create it. I'm just using whatever GitHub provided. So it's giving the minimum score per language for all the repos that do not have a wiki. And then you call it again. It's the same thing for all the repos that do have a wiki. But if you've ever, and for those of you that haven't, I guess now is a good chance. Just fire up Microsoft Excel and just Google pivot tables. It's essentially the same thing, but it's all in Python. So any questions about that? Okay.
So one of the things is, so Meza is providing a lot of functions that let you transform generators or iterators into other generators or iterators and so forth.
Exactly, yeah. So basically what he was saying is Meza lets you transform generators of records, into other generators of records. And yeah, that's pretty much what it does. And here, this is for those of you that like a graphical example. So this was before I applied pivot. So these were the fields: the name, the language, the score, and whether or not it had a wiki. So this was before pivoting, and this is after pivoting. So now we pivoted it, and so now we just have, does it have a wiki, yes or no? And then instead of language being a field, we have each individual language being a field. And the value that's in there is now the minimum of all the repositories with that language. So this is the minimum score of each repository for a given language, and broken out by whether or not it has a wiki. So I'll just go back so you can see. This was before. So this was kind of like the normalized structured view. This is something that you could put in a database. And then this is kind of like the denormalized version. So any questions about that? Okay. All right. Now exercise 2. So this is also a mountain in Tanzania. You can see it from Arusha. So I took this picture a few towns over from Arusha. So Mount Kilimanjaro is the tallest mountain in Africa. So it's a lot larger than Mount Meru. And it should also kind of give you an indication on the difficulty of this exercise. So, okay, so exercise number 2. Display the language with the most number of watchers per owner type per has pages. And owner type is also from the GitHub repo. So one of the fields is just called owner type, and it will either be public or private. And then has pages will either be true or false. And what you should get is a data structure that looks something like this. So you'll have a dictionary, has pages, in this case is true. The language is, in this case, JavaScript. The owner type is organization, and then the watchers is 128,000. So what this means is that JavaScript has the most number of watchers for repositories that have pages and are an organization. So sorry, when I said owner type was public or private, yeah, owner type is either organization or something else that means like individual. I forgot what it was called. So, any questions about the exercise? Because it's very important that you understand what you're trying to do. Yeah. Right, yeah, and so the question was about the arguments that pivot takes. Yeah, so it might be a little difficult if you've never actually used pivot tables in Excel, but essentially it takes multiple rows that kind of tell you what you want to do. So in this case, you can see how there's a field here called score, and it has values. So when we go here, we had to tell it that look at the field called score, and out of all the values you get, apply some kind of aggregation. And in this case, we're saying apply the min. So it was giving the minimum of the value of all those scores. But if you go to there's a link in the exercise to the Meza library, and the library has doc strings, so it explains all the arguments. Okay, so any other questions about the exercise? Is there someone who does not understand the point of the exercise? Okay. Okay, so the data source is going to be a bit different. So in this case, for the API, the query is still data, but we're going to say sort by stars and then order descending. I mean, it doesn't really matter because the results from the API are still the same structure. So it only matters if you want to get exactly the same answer that I got. But any call to the API will let you do what you need to do. But this is the URL that I used, and it's also in the files. So if you're in the exercises file, the URL is already there. And then here is just a hint for some of the things that you need to use. So in Meza, there's a function called Flatten. So one caveat about Flatten is that since Flatten is in the FN tools module, instead of taking an iterator of records, Flatten takes an individual record. So that's one difference. So you looked a little confused.
No, I got
Okay. Okay. So that's one caveat for Flatten. And then there are multiple ways to solve this problem. So depending on how you do it, you can either use the normalize function from Meza or the aggregate function. And this is the link to the notebook. It's the same link as before. So it's just the exercises.ipybn. So the exercises notebook, or if you're using Python, it's just the exercises.py. Okay, so we have, let's see, let's do 15 minutes and then see where people are after that. Okay, so there's 5 minutes left. So I'll just go ahead and show you the solution I came up with. Okay, so this should look pretty familiar. There's a few different imports that you might not have come across yet. So yeah, there's this func tools partial. So that's just doing partial application with Python. I'm using a new URL, so I have the URL 4. So I just create the file like object. Once I have the file like object, I can use read JSON. I use the FillEmpty function that I told you guys about. So I'm filling in all of the empty language entries with just a empty string. I mentioned Flatten. So one thing is that the GitHub API returns a nested structure. So the owner field is actually a dictionary. And we need to flatten that out to access all of the attributes that are under that. So here I'm just using a list comprehension. You could also use the map function to do the same thing. But essentially I just want a flat data structure. And so next we're just going to set up the different fields that we're going to group by and potentially aggregate by. So that's the args and the rows. So first we're going to pivot. And so we're going to pivot just using kind of these args and rows that are defined here. And the operation that we're going to be doing is summing. And here I'm just doing a peek so I can show you what it actually looks like with the preview. So far, after we've pivoted, so now each of the languages are broken out and we have a sum of that value field. And the way we were pivoting it is by whether it has a page and the owner type. So you can see those fields there. That's what we have so far. So now that we've pivoted, we want to do kind of the inverse, so we're going to normalize it. And this is just so we can kind of get it back into the original kind of structured data format. So one thing to note here is that I'm using the keyword argument invert, and that's just so that I can keep that rows variable that I had already defined. And so what invert is saying is that this rows, so I'm going to normalize everything except the arguments that are in rows. If invert was false, which is the default, then it's going to normalize the rows. But we want to normalize everything that is not the rows. And so you can see here, I do another preview, and you can see here, now it's normalized. So instead of each language being the key, now the key is called language and the value is the individual language. And the reason we did that is because later on, we need that kind of structured view. And we have the sum of watchers, which is already there. And so yeah, if you look here, so watchers wasn't in here, but you see once we normalized it, we get that watchers variable. So I'll just go back and forth so you can see the difference. So that's what normalize was doing. So it added the language field and it added that watchers field. Just to go back and forth one more time. So now we have that data structure, and now we're going to group. And so in this case, one thing I mentioned to you is that group takes an aggregator function. So that's what we're going to do here. So we're going to have a custom aggregator function that is going to calculate the maximum number of watchers. And so we're using this partial that I mentioned a bit previously. So we're going to essentially create a new function which calculates the max, and the key function, this a key func that's defined in that first row is just going to be watchers. So that gets passed into the aggregator, and then the aggregator is the keyword argument to group. And then we have this G key func, which is just how we're grouping it. And so we're grouping it by the rows variable that we already defined. And so now once we've grouped it, now watchers is going to be that max value. So we have the max language per has pages per owner type. And the last step is just to sort it. And so we just use the sorted function, the same key func, and then we have reverse equals true, so that we have from largest to smallest. And then at the end, you get something like that. So I think it's at the end. Yeah, and the solution is also online. So, but yeah, it's 12 o'clock. 3 o'clock. So yeah, free to go. But I'll be here if you have any questions. You can just come up and ask me. So.